In this video, we will see dry run of the code. Now let's understand the dry run of this code. So basically here, I will start with this one. First of all, sort the array, right? So I will sort the array. So you can see this is my array and this is my sorted array. Okay. Then S will be my 0. I will take S pointer that will be at 0. And I will take N pointer that will be AR of N minus 1. What is AR of N minus 1? That is 91. Basically the last element, right? So what is N here? Let me see. That is 3, 3, 6 and 9. So we have 9 elements, 9 minus 1. So this cell 0, 1, 2, 3, 4, 5, 6, 7, 8. The 8th element. Okay. 8th index element. Okay. So let me construct that one also. Basically how I am applying binary search. So that is a range of 0 to 91. So what I will do, see, I will create one rest variable. So one rest variable is created. Let me create it here. Okay. And I will say when S is less than equals to E. So yes, S is very far less than equals to E. Basically starting point is less than the end point. So find out the mid. Mid will be S plus E by 2. So that is our 45. So 45 is our mid. Okay. Now once we got the 45, I am calling this if place function with the mid value. I am calling this place function with the mid value. Now let's see. So your starting point, okay, starting range I have started written basically this is your starting point. So can I say let starting point will be your array 0, right? Your end range, basically your end point, okay, or let me put range. Let's don't make confusion. So starting range will be your 7. Your ending range will be 7 plus mid plus mid. So 7 plus 45 plus 45, right? So it will be 7 plus 45 plus 45. You can see 45 plus 45 that is 90 and 97 it will become basically 97. Okay. So yes, it will become 97 and I will say routers is 1. Now from here, I will check when I is equals to 1, my pointer will be here and I will check is your array I is greater than the end range. What is my end range now? That is 97, right? So 26 is greater than end range? No. Is 45 is greater than end range? No. Is 52 is greater than end range? No. Is 65 is greater than end range? No. Is 69, 73, 88, 91? No. None of the house, like none of the house is not greater than the end range. So can I say my only one router will basically give Wi-Fi supply to all the routers? Yes. So router is 1. I will come to here and 1 is less than equals to k. Basically 1 is less than k. So I will return true and I will return true here. When I'm returning true, basically, okay, that's not the answer. You can say that is answer here. Instead of res, it should be res here then. Or here I'm returning answer. Sorry, my bad. So that will be not res. You can say answer, right? Let me say answer here. So answer will be basically the mid range. What was that? Was 45. I will call and is equal to mid minus 1. I will call for mid minus 1. So when I'm calling for mid minus 1, that is 45 minus 1, that will be 44. Okay. So now what I am getting here, basically end minus 1. I won't execute. I will again check is S is less than equals to E. Yes, it is. 0 is less than 44. Calculate the new mid. The new mid is 22. New mid is 22. Again, I will place mid then in my this place function. I will place my mid. Right. So when I am placing my mid, again, let's see. Right. When I am placing my end, what will be my start range? That will be again 7. What will be my end range? That will be 7 plus 22 plus 22. What is the end point? That is 44 plus 7. I guess that will be 51. Right. So 51 basically somehow here. Right. So these many houses will be covered. Right. So I will check. I will again start from 1. So I will start from here. Right. I will check. Is area is greater than end range? 26 is greater than end range? No. Right. I will come here. Is 45 is greater than end range? No. Is 52 is greater than end range? Yes. 52 is greater than the end range because it was 51 only. So my new start range will be array I, that is 52. My end range will be again array I, that is basically 52 plus 22 plus 22. That will be 44 plus 52. 44 plus 52 will be 6 and 96. Okay. So it will be now 96. Okay. Now again I will calculate and my router will be router plus plus. So here it was router 1, right? From 1 the router will be 2. Okay. And again now after this I plus plus I will check the new I array I is 45. Sorry, 52 till I have checked. I will check. Is 65 is greater than 96? No. Is 69 is greater than 96? No. Is 73 is greater than 96? No. Is 88 greater than 96? No. Is 91 is greater than 96? No. And that's end. And I will return if routers is less than equals to k. Yes, router is 2. We have k that is equals to 7. Okay. So yes, it is less than, return true. So I will return true. And again, I will store my answer. So from 45, I will store 22 in my answer and I will call again mid minus 1. So I will call mid minus 1. It will be basically again now 22. Basically mid minus 1. So 22 minus 1, that will be 21. Again, I will check. So I will basically check, is S is less than equals to E? Yes, S is less than equals to E. Again, I will calculate the new mid. Now my new mid will be 10. Right. Once my new mid is 10, what I will do? Okay. I will again call this place function with the array mid. So when I am calling this again place function with the array mid, what will the new values? Let's quickly see. Okay. So when I am calling this, my start range will be again array 0, 7. Okay. My end range will be 7 plus 10 plus 10. That will be 27. Okay. And I will check from 1. Router will be again 1. Routers will be again 1. Okay. And again, I will check from here. So let me remove this one. Again, I will check from here from 1 point. Is 26 is greater than the end range 27? No, it is not. Right. So router will be 1. That means this house is already covered in the router 1 because the position was 7 plus 10, that is 17, right? Position will be here. So minus 10, it will be 7, plus 10, it will be 27, right? So this house is already covered. I will check the next house. Is 45 is greater than the end range? Yes, 45 is greater than 27. So now my new range will be start from 45 and it will be 45 plus 10 plus 10. That will be 20 plus 45. That means 65. Okay. 65 and my routers will be now 2. Again, I will check, right? My I pointer will be to new. This one is done. I will come to 52. Is 52 is greater than 65? No. Move ahead. 65 is greater than 65? No. Move ahead. 69 is greater than 65? Yes, it is. Right? So again, what I will do, I will create the new position will be 69 and it will be 69 plus 10 plus 10. That means 89, right? And routers will be 3. Okay. Then again, after this, I will check, is 73 is greater than 89? No. Is 88 greater than 89? No. Is 91 is greater than 89? Yes. So my new position will be 91. Okay. And it will be 91 plus 10 plus 10. That means how much? 111. Right. And that's it. I will do routers plus plus, then the routers will be 4. Okay, and I will come here right now. This is the end of the loop. I will come here. Is the router less than equals to k? Yes, it is. Routers are 4. We have k equals to 7 routers. So I will say yes, that's a true. Store the answer. So now my answer will store this value, that is 10. And I will say again look for the lower value. So I will say call mid minus 1. That means my end will be now 9. Again, I will check, is S is less than equals to E? Yes, 0 is less than equals to 9. I will check what will be my new mid. New mid will be 4, right? 4. Again, I will place 4 and I will do the same. Right? So now I am not doing here because that's enough space. But basically, this is how our our code works, right? I hope you got the dry run. This is nothing like very easy program, right? Not that complex. Basically, I am just checking is the given house is in my range or not, right? So that's all about dry run. And yeah, we have completed. Just remember that here, this is not rest. This will be an answer. Okay. So yeah, that's all for this one. Now let's quickly, we are end of the video. So let's quickly discuss the time and space complexity here. So what will be the time complexity here? Can I say log of n? Because binary search, it should be log n. But see, n is about the basically number of the elements, right? Here we don't have only 5 elements, right? We don't have any 5 elements. So it should not be log n. It will be the log of your maximum range because you are taking from 0 to your max 91, right? So basically it will be log of where I can write, I will write it here. It will be the log of your max range. What was your range? 91. So it will be log of 91. And if I am saying now 91, so can I say it will be the log of, let's take maximum range. It will be log of maximum range. And during that log of maximum range, right, on each iterations, these are basically these will be the total number of iterations. In all these iterations, what you are doing, you are running a for loop that will take n, that will run for n times because you are checking all the number of houses n. So it will be n log of your maximum range. Okay, so that will be the time complexity. Let me put it here. Okay, so it will be n into log of your maximum range. Basically, this maximum range is always right. You can take basically your last endpoint after sorting. Also, we have missed one thing, that we have sorted the array. So can I say this sorting will also take time? That is n log n, right? So now let's understand this n for my for loop or a loop running n. This is for sorting and this for advanced binary search. Okay, this is for advanced binary search, and basically the now overall time complexity will be maximum of n log the range, max range, or the n log n, whichever is maximum, right? Whichever is the maximum will be the time complexity. What about the space complexity then? Okay, so are you taking any extra space? You are taking only that variable. You are not taking any extra space, right? So the space complexity will be big O of 1, that is constant. So no space complexity, only the time complexity, that will be this. Okay. So yeah, that's all for this problem. Again, one very good problem on advanced binary search. Try to solve it. Try to solve more problems on advanced binary search. Now you will get a complete context and you will solve all problems related to advanced binary search. So that's all for this video. Thank you and see you in the next video.